that we introduced equivalence relations, we're going to expand the idea, have some new definitions, and try to analyze what's going on for this new definition. Definition of congruence. Mod D. Suppose you have two integers. Let m and n be two integers. Let d be a positive integer. We say that m is congruent to n mod d modulo d or mod d, and we write it this way: m is congruent to n mod d if and only if d divides the difference between m and n, or from what you remember, there is an integer like k such that m minus n is equal to kd. Okay, for example, "12 is congruent to 7 mod 5y, since 5 divides 12 minus 7, which is 5. So this relation is a correct relation." Another example for you. "6 is not congruent to -8 mod 4. Okay, let's check to see if it satisfies the definition or not. 4 doesn't divide 6 minus -8, which is 14. That's obvious. 4 is not a factor of 14. Very good. Whenever you have an equivalence relation like mod D, the congruence relation, you can define equivalence class of each element. So let us write this note down here. Note: congruence mod D is an equivalence relation. Let's write this definition down. Definition of equivalence class. Suppose you have a set. Suppose A is a set and R is an equivalence relation on set A for each element, for each member in A, like A. We can define the following set. We define the equivalence class of A denoted by bracket A. It's defined as follows. The equivalence class of A is the set of all elements in set A that are in relation with A. So the equivalence class of an element is a set including all elements, all members of set A that are in relation with A. So X is in relation with element A. So you can say that, hey, X is a member of this set if and only if X is related to A. Give us an example. What are you talking about? Take a look at this example. I'll give you set A with members 0, 1, 2, 3, 4. And I give you a relation like R, which is defined as 0, 0, 0, 4, 1, 1, 1, 3, 2, 2, 3, 1, 3, 3, 4, 0, and 4, 4. Okay. This is an equivalence relation. I'm going to define the equivalence class of each member in A. Equivalence class of 0 is the set of all elements in A that are related to 0. What members are related to 0? 0 is related to 0, so you're going to write down 0. What else do we have? 4 is related to 0, so you're going to write down 4 as well. So the equivalence class of 0 has 2 members. The cardinality of equivalence of 0 is 2. What about equivalence class of 1? You're looking for all members in A that are related to 1. What is related to 1? 1 is related to 1. So this set includes 1. 3 is related to 1. So you're going to copy down 3. So the cardinality of equivalence class of 1 is also 2. Let us move on to next equivalence class. Equivalence class of 2 is the set of all elements in A that are related to 2. What elements are related to 2? 2 is related to 2, and that's it. So this guy has only 1 member. The cardinality of this set is just 1. So what about equivalence class of 3? We're looking for all members in A that are related to 3. Okay, what is related to 3? 3 is related to 3. 1 is related to 3. 1 and 3. What about the equivalence class of 4? We're looking for all members in A that are related to 4. What members are related to 4? 4 is related to 4. 0 is related to 4. So 0 and 4. Note that the equivalence class of 0 is the same as equivalence class of 4, and the equivalence class of 1 is the same as equivalence class of 3. All right.